Now moving forward, let's consider section B here, which is numerical value type, and the first question is talking about let A equals n from the set of natural numbers. N is a 3-digit number, 100, 101, 102 and so on. B, 9k plus 2, k is a natural number, so this is of the kind 9k plus 2. C, 9k plus L, k is a natural number for some L in the interval 0 to 9. So question is simply talking about that A, B, C are 3 sets. The sum of all the elements of the set A intersection B union C is 274 into 400. Now there are 2 possibilities I can think of, like L is something between 0 to 9. If it is particularly 2, then B union C will be same because B and C both will be same in that case. If I consider L is other than 2, then I need to write both as total elements of B plus total elements of C so that I can find that sum. Now let's move with this approach considering as the different other than 2. So the required sum is equal to summation k is equal to 0 to 99, and here I can simply say let's do one thing, add 99 so that this becomes a 3-digit number and you can get intersection with A, correct? So this is 99 plus 9k plus 2 plus 99 plus 9k plus L, right? So just add it. This is coming as 99 plus 99 plus 2, that is 200 into 100 plus 9k that is 18, and k is 0 to 99, so this becomes into 99 into 100 upon 2 plus next is L, so this is 100L. Now this value is given to me what? 274 into 400. So let's say this is equal to 274 into 400. I'm sure this is clear, right? Now I can cancel some zeros and all. So what I will be getting here, 200 plus this 100 is cancelled again, 9 into 99 plus L is equal to 274 into 4. Just simplify further, you obtain L is equal to 5. So yes, the correct answer for this question is coming as 5. So let's write here, the required value here is 5. I'm sure this is clear. Let's take up the next one. If minus a to a integral mod x plus mod of x minus 2 dx is equal to 22, where a is greater than 2. Question is talking about integral a to minus a x plus greatest integer x dx. So if I consider this one, mod x and mod of x minus 2, I can clearly say, let's start writing this term first, minus a to a mod x plus mod of x minus 2 dx is 22. Now clearly this can be written double of 0 to a x dx. So double of 0 to a x dx plus this one we can break at 0, minus a 2 we can break at 2, minus a to 2. This time we can see that x minus 2 would be negative, so I need to write it 2 minus x dx plus integral 2 to a x minus 2 dx. This is equal to 22, what is given in this question. I'm sure this is clear. Now just simplify. This gives us x square by 2, 2 will be cancelled, so this is a square plus. When you write this term, you can see that this is 2 minus x, correct? You can whole square directly, you can write it as 2 minus x whole square upon minus 2. So this can be written as 2 minus x whole square upon minus 2 within the boundary minus a to 2 plus. Next is x minus 2 whole square by 2 within the boundary 2 to a. This is equal to 22. Also you can plan using just the diagram. From there you can get directly the result. So it gives me a square plus. When you put the upper limit, obviously it is 0. When you put the lower limit, it is a plus 2 whole square divided by 2, because minus of minus will be cancelled, plus when you put the upper limit, this is a minus 2 whole square upon 2. When you put the lower limit, it becomes 0. Clear on it? All right. Just simplify this term to get the value for a. On simplifying, you get a is equal to 3, as the equation obtained is a square equals 9. A is greater than 2 given to me, so obviously a is 3. Now, what's the requirement? Let's check out. We are looking for integral. Let's write down. Therefore, 3 to minus 3 x plus greatest integer x dx is equal to 3 to minus 3 x dx, that's simply 0. For the other one, let's write it minus of minus 3 to 3 greatest integer x dx. Just break it in the intervals. You can say minus 3 to minus 2 minus 3 dx, and the rest terms will be cancelled, giving you result simply as 3. Now time to write the required final answer here. Question was asking for the value of this one, so obviously this is coming as 3. I'm sure this is also clear. Let's take up the next one. Let P, a matrix, is given. Suppose Q is a matrix satisfying PQ equals k times I3 for non-zero k from set of real numbers. Q23, one particular element, is minus k by 8. Determinant of Q is k square by 2. Then alpha square plus k square. Lots of equations are there. Just plan for simplification. If I start with determinant of P, so this would be 3 minus 1 minus 2, 2 0 alpha, 3 minus 5 0. Just simplify it. This gives you 3 times 5 alpha plus 1 multiplied with minus 3 alpha minus 2 multiplied with minus 10. So this is giving me simply 12 alpha plus 20. This is determinant of P. Clear? Now, it is given to me that PQ is KI3 and determinant Q is k square by 2. Correct? Now, since PQ is KI3, so obviously determinant P, determinant Q is equal to k cube. Clear? All right. Now, we have determinant P as this term, also given to me that determinant Q is k square by 2. So determinant P into k square by 2 is equal to k cube. That means determinant P is equal to 2k. Determinant P is 2k and that is also 12 alpha plus 20. So we have the result from these two equations. From 1 and 2, we conclude that 6 alpha plus 10 is equal to k. This is one more result. Next, what we have not used yet. This is element Q23 is minus k by 8. Q23 is element from matrix Q. Q can be obtained from here by multiplying by P inverse. Since Q is KP inverse. So can we plan for Q23? This is given to me as minus k by 8. Now how to find this Q23? Using this one, k into P inverse. So this is k into, now inverse of P. Since you are talking about 2, 3 and inverse of P meaning how you will be forming? Using the cofactors and taking its transpose. So 2, 3 will be obtained when you are taking cofactor for 3, 2. That means for this element. And what that would come? That would come as 3 alpha plus 4. Correct? With a negative sign because you are talking about 3, 2 cell. Also to be divided by determinant P as you are dealing with the inverse part. So right here minus of 3 alpha plus 4 divided by determinant P, you can write 2k is equal to minus k by 8. Clear on this point? Now, what we obtain here, this k is cancelled, minus is also cancelled. So here we have simply on cancelling 2, we are getting 4 here. So we get 3 alpha plus 4 is equal to k by 4. Now let's put it as equation number 4. If you take equation number 3 and equation number 4, you can simply plan to get the value for alpha and k, right, from 3 and 4. What to do here? Just see. Equation number 3 is saying 6 alpha plus 10. Here you have 3 alpha plus 4. So let's multiply it by 2 and simply subtract. On subtracting, you will be getting 10 minus 8, that is 2, is equal to k minus k by 2, that is equal to k by 2. So the value of k is coming as 4. Put the value of k in any of the two equations, either in 3 or 4, so that you can get alpha. When you put k4 here, you get alpha as 1 minus 4 divided by 3, that is minus 1. So this is the value for alpha. Therefore, alpha square plus k square as required, this is simply 1 plus 16 is equal to 17. So we obtain here the answer as 17. So let's write down this result here. The required value is 17. Let's move on to the next question now. If one of the diameters of the circle x square plus y square minus 2x minus 6y plus 6 equals 0 is a chord of another circle whose center is at 2, 1. Simple question, then the radius they are asking for. So let's consider there is a circle, correct? Now, question says one of its diameters like this, correct, is a chord for another circle for which this diameter is a chord like this, correct? Now the question is saying simply that this is one center of the given circle, and the given circle's center we can see is simply 1, 3. The required circle center is 2, 1. Now, what is the radius of the given circle? From here you can see 1 plus 9 minus 6. So this radius is coming as 2 units. What we are looking for? We are looking for the radius of the next circle. That means this portion we are looking for. Simple geometry is there. Let's say this is P, this is Q, and this is R. Therefore, PR is equal to root of RQ square plus PQ square. Now, this is equal to root of RQ square, meaning 4, plus this distance we can find as 1 plus 4, that is root 5. Its square is 5. So the required radius is 3 units. So simply we get the answer over here as 3. So I'm sure this question is clear how we are getting the correct answer. Let's move on to the next question of this section.